right? So therefore, actually this can be rewritten as actually, suppose you can take for 2-dimensional. Suppose to understand this problem, you can take for n equals to 2, n equals to 2 for convenience, you understand. So this is nothing but what? Xi minus x1 minus y1, x2 minus y2. What is d2? D2 is nothing but x1 minus y1 whole square plus x2 minus y2 whole square, right? Whole power 1 by 2, right? Whole power 1 by 2. So therefore, so this is nothing but actually remove the whole power 1 by 2 square root on right side. So this is nothing but what? Actually this can be rewritten as, this x1 minus y1 whole square plus x2 minus y2 whole square plus 2 into x1 minus y1 plus into x2 minus y2, right? So this is looking like a plus b whole square, right? This is looking like a plus b whole square, right? Because this is a non-negative constant. Already I told you so many times, this is a non-negative constant. Therefore d square is always less than or equals to this a plus b whole square. That means what? What is d2? d2 of x comma y. What is this bracket term? Bracket term is nothing but what? d1 of x comma y whole square. That means d2 square is less than or equals to d1 square. That means d2 less than or equals to d1. That means d1 minus d2 is non-negative. So that we are not getting this is negative. This is always non-negative. So there is no problem with first condition. Understand? So that we have tried yesterday, so that we are not getting that answer. Is it clear? So this is always non-negative. So d is always non-negative here. But what the problem? The problem is that actually, see, what is my guess is that second condition. If you take my second condition, d of x comma y is 0, right? If you take d of x comma y is 0, that means d1 of x comma y minus d2 of x comma y is 0. That means d1 of x comma y equals to d2 of x comma y, right? Right? So if d of x comma y is 0, that means distance between x comma y with respect to d1, distance between x comma y with respect to d2, both are same. So what I do is that I need to find two elements. I need to find two elements which are in R power n, whose distances with respect to d1 and d2 are same, but x1 x not equals to y. If you give me two elements which are n tuples, which are distinct elements, whose distances with respect to d1 and d2 are same, but they are different. Can you give me such elements? Can you give me x and y which are different, but whose distances with respect to d1 and d2 are same? Yes, we can give. Suppose I can give 1 0 0 0 0, y equals to 0 0 0 0. So what is d1? What is d1? So what is d1? So d1 is nothing but d1 of x comma y is nothing but what? 1 minus 0 plus 0 minus 0 going on 0 minus 0. That means what? 1. What is d2? d2 of x comma y is nothing but, you know, that is a Euclidean distance under root of 1 minus 0 whole square. That means 1, right? So d1 of x comma y is equals to 1. d2 of x comma y also 1. Therefore, what is d? d is equals to d1 minus d2. That means what? 1 minus 1 0. So d is 0. That means what? d of x comma y is 0, but x not equals to y, because x is different from y, because 1 the first place it is 1. The first component of x is 1, where the first component of the y is 0. So the first places of x and y are different. So therefore x not equals to y. Therefore second condition failed. So therefore it is not a metric. Is it clear the idea now? So therefore it is not a metric. Is it clear? Put it in chat box. We have tried yesterday. The property is always true. What you have done is that we are trying to show that that is wrong. Understand? We are trying to show that that is wrong. So that is absolutely wrong, right? Okay. So this is a problem actually. What actually summation d. So this is a problem actually. I want to tell you. I want to tell you. Suppose Suppose. So what is the problem? Actually, okay. What is the problem here? Yeah, this one. What is this one? Set of all real sequences. Just I can take here. Set of all real sequences. It is what actually? Set of all real sequences. So what is my d of x comma y? My d of x comma y is nothing but summation I equals to 1 to infinity 1 by 2 power I mod of xi minus yi divided by 1 plus mod of xi yi. So what is my x? X is a real sequence. X1, x2 going on. Whose components are real? What is my y? Y1, y2, y3 going on. So this is my actually my function. So no. So this is my function. What is my function? So this is my function. 1 by PA, sorry. 1 by PA. Understand? 1 by PA, not 2. So you know that actually, suppose you take this as PI, right? So if you take P equals to 1, there are so many possibilities. I already told you. So suppose P equals to 1, what happens? Suppose P equals to 1, what happens? This metric is nothing but actually, this function is nothing but xi minus yi divided by 1 plus xi minus yi, right? This is my d of x comma y. This is my function. Question is that, is it a well-defined function? Is it a metric? The answer no for p equals to 1. Why? Because if you take x equals to 1, why? If you take x is my sequence 1 0 0 0, right? If you take my sequence 1 0 0 0 0 0, if you take my y sequence is constant sequence 0 0 0 0. So what is my distance between x and y? Is nothing but what? Summation I equals to 1 to infinity. What you're getting? What you're getting? At only first place it's surviving. That means what? 1 minus modulus of 1 minus 0 plus 1 minus 0. That means what? 1 by 2. You know, it's a constant function. Therefore, it is not a metric. For p equals to 1, what you're getting is that, so what you're getting is that, see, the idea is that actually, in fact, this series is actually, in fact, it's not convergent. In fact, if you take the series as it is, I equals to 1 to infinity, summation I equals to 1 to infinity, this series is not convergent because nth term doesn't converge to 0. So therefore, what is the problem you're getting? This series is not convergent. This series is not convergent because it is a constant term. Understand? It is a constant term. So constant term never converges to 0. Understand? It is a constant term. Xi is a constant, yi is a constant, 1 plus xi minus yi is a constant. Therefore, it is a constant term, need not converges to 0. Therefore, this function is not a metric for p equals to 1. So you know that in basic real analysis, you know that see, I need actually this to be convergent. I need this to be convergent to well-defined function. Why? Because if you take any, suppose if you take a p, suppose you take p bigger than 1. What is the problem? If you take p equals to 1, you are getting a problem, right? If you take p bigger than 1, suppose if you take p equals to 2, p equals to 2, what happens? 2 power I xi minus yi divided by 1 plus mod of xi minus yi. Sorry, right? So therefore, this is nothing but this. Question is that, suppose I can take p equals to 2 for loss of generality, without loss of generality. So therefore, what happens? What happens? Is that convergent? Is the series convergent? Is the series convergent? The answer yes. You know that actually, so xi minus yi is always less than 1 plus xi minus yi. This is always true, right? So therefore, xi minus yi divided by 1 plus mod of xi minus yi is always less than 1, right? So therefore, when you take actually 1 by 2 power I, when you multiplying on both sides 1 by 2 power I, the inequality doesn't change because actually 1 by 2 power is positive, right? So you know that by this is the geometric series. By comparison test, this series is always convergent. This series is convergent for I equals to 1 to infinity because you know that r power n is equals to 0 to infinity or 1 to infinity is convergent if and only if whenever this is less than 1. right? So therefore, this is always convergent, right? Right? So therefore, this series is convergent means what? By comparison test, this series convergent. I equals to 1 to infinity xi by 1 plus this 1 by 2 power I. This series convergent. This series is convergent. So therefore, your distance function is meaningful. This is a real number. Is it clear? Is it clear the step? Put it in chart box. Right? Is it clear? Put it in chart box. Okay. So therefore, is it clear, Amma? Hello? Put it in chat box. Yeah, okay. Okay. So therefore, this is convergent. See, the main problem, this series actually, when you take p equals to 1, this series may not convergent. That is important idea. That is important idea, right? So that is not, so that is what actually, if you take p equals to 1, this series is not convergent. For p bigger than 1, this series always convergent. If you take a p is replaced by constant p, nothing wrong, because p is bigger than 1 means what? 1 by p less than 1. Understand? So whenever 1 by p less than 1, automatically this means 0 less than, that means this satisfying this condition, mod r less than 1. Whenever mod r less than 1, this is geometry series, this series always convergent. Not only 1 by 2, you can replace any convergent series. This 1 by 2 power I is replaced by any convergent series. Suppose you can take I equals to 1 to infinity by I factorial. Understand? This is also convergent. This series also convergent. Right? So this is very important argument. Xi minus Ya divided by 1 by 1 plus Xi minus Ya. Therefore, this series convergent. Why? Because you know that, by DLM test, that this series convergent. Right? By DLM test, this series convergent. In basic ray analysis, this series is convergent because what? My limit is what? Limit n tends to infinity, limit n tends to infinity, 1 by n plus 1 factorial into n factorial. This is nothing but 1 by n plus 1. This is nothing but limit is 0 less than 1. Therefore, this series is convergent. So if you replace this by any convergent series, this is meaningful function. That's what my point. Not only 1 by 2 power I, you replace this by any convergent series. This function, whatever function you define, that series is convergent. If you know this step, then remaining part is trivial. The answer is over, right? Why? Because distance, this is non-negative, mod is non-negative, this is non-negative, 1 by 2, this is also non-negative, totals, this is one non-negative, so distance is non-negative, right? And distance is 0. If you know the distance is 0 means what? This each piece is 0, each term is 0. That means what? This 1 plus xi into yi, this is 0. 1 by 2 power I is 0. Therefore, but this is never 0. That means if and only mod of xi minus yi is 0. That means xi is equals to yi for all I. Therefore, what? X equals to y. So all the conditions are true. That it satisfies symmetric property also, because mod of xi minus yi is same as saying that mod of yi minus xi. So it is symmetric. And what about the triangle inequality? Already yesterday I told you this is a metric. Already we have shown that this is a metric. So therefore, using that metric definition, this is true. This is always true. This is less than or equals to mod of xi minus zi. Already we have shown that this is a metric. Right? This is a metric. We have shown that this form is a metric. D by 1 plus D is always a metric. Already I told you. Right? So this is true for every I. So therefore, take 1 by 2 I. You need to multiply with both sides by 1 by 2 power whole power I. 1 by 2 power whole power I. The inequality doesn't change because this is a positive. So therefore, take the summation. Right? The summation I equals to 1 to infinity. I equals to 1 to infinity. So what is this? This is d of x comma y. What is this? D of x comma z. What is this? D of z comma y. Therefore, triangle inequality holds. Is it clear? Is it clear the idea? So what is important step is you can replace this by any convergent series, and remaining part is very trivial as usual by on par with this metric. Right? Mod of x minus y divided by 1 plus mod of x minus y. On par with this metric, one can prove easily. Yes or no? Is it clear?
Yes, sir.
Yes. So what do you understand? That is important. right? So just now try to solve this problem. What is actually here? Yeah, this one. So already I told you, if you take p equals to 1, p equals to 7, is it a metric? If p equals to 7, 1 by 7, what is this? If p equals to 7,
Yes, sir. Convergent series.
that convergence series by geometric series. So therefore, right? So therefore, what happens? So therefore, this is nothing but what actually, if you take p equals to 1, p equals to 7, what happens? D of x comma y is equals to summation I equals to 1 to infinity 1 by 7 power whole power I 1 by 7 whole power I xi minus ya modulus of this is 1 plus mod of xi minus ya. Therefore, already I told you this is a convergence series by geometric series. Therefore, this is a metric, right? So second option, look at the second option. X is a metric space with respect to the metric if p less than 1. Is it true? Is it true? If you take p
No,
equals to
sir.
1, if you take p
Less
equals
than
to 1,
7.
if you take p equals to 1, in fact, if you take p equals to 1,
It is not.
yeah, that's it. So third option, X is a metric space with respect to metric if p bigger than 1, always.
Yes.
Yes, 1 by p less than 1 by 7. Yes or no? So
Yes.
therefore, this is a convergent series. This series is convergent. What series is convergent? 1 by p power I is convergent series. So therefore, it is a metric. So X is a metric space with respect to metric if p equals to 1. Is it true?
No.
No.
No, sir.
See, don't annotate it. Okay. So therefore, so p equals to 1, it is not a metric. Is it clear, all of you? Put it in chat box. Put it in chat box. Mute all. Mute. Alpha is a real number, and this is a step function is the greatest integer function which is less than or equals to alpha, and d is a function which is defined by like this. Which of the following statements are true? You know that step function, you know that already know, greatest integer function. You know, this is my 0, this is 1, this is my 2, this is my 3, this is my 4, going on. This is my -1, this is my 2, -2, going on. This is my 1, this is my 2, this is my 3. You know that whenever 0 goes 0 to 1, it is always 0, step function, right? 0.01 is equals to always 0. 0.02 is also always 0, right? Like 0.0999 also, it is always 0. Therefore, 0 to 1 always 0, and 1 to 2 is always 1, right? 2 to 3 is always, see some disturbance. Right, 2 to 3 is it is 2 to 3 is nothing but what? Suppose if you take 2.9, what you are getting? 2, right? 3 to 4 is always nothing but 3. So it is a like step function, right? You know that. Is it clear? So it is a step function, right?
Yes, sir.
Right? Yeah. Now my question is that what is my function? My function is d of x comma y is equals to step of modulus of x minus y. This is my function whenever x comma y belongs to R. Question is that is it a metric? First of all, what is my first option? D of x comma y 0 if and only if x equals to y. Is the option true? What is my first option? D of x comma y equals to 0 if and only if x equals to y. Answer true? Yes or no? Again, already told you, go back to guess method. If p of x comma y is 0, what happens? Step of modulus of x minus y 0. That means step of modulus of x minus y 0 already. When do you say that step is 0? When do you say that step is 0? Step function is 0 whenever the x lies between 0 to 1. Yes or no?
Yes.
So that means this lies between 0 to open 1. Right? 0 to open 1. So I can adjust. Now I can adjust. I can take suppose x equals to what to take actually? X is equals to 1, y equals to 0.2. So no, not 0.5. As your wish. Right? Now what you do is that what is the distance between x and y? What is the distance between x and y? Modulus of step of modulus of 1.0 minus 0.2 step of. That means what? 1 minus 0.2 is nothing but what? Step off. 1 minus 0.2 is nothing but what? 0.8. So step off, modulus of 0.8 is nothing but 0.8. So step of 0.8 is nothing but 0. So distance between x and y is 0, but x is not equal to y. Distance between x and y is 0, but x not equals to y. Right? So this condition fails. Is it clear? So this is not true. This is not true. What is the second condition? Symmetric. Is the symmetric true? Look at this option B. Look at, see, is it true? Did you understand?
Yes, sir.
Okay.
Addition up to metric spaces always symmetric.
Hello?
So
Cheppandi.
addition of two metric spaces is always metric form. X minus mod x minus 2 metric అవుతుంది 2y అనేది కూడా సెకండ్ ఫంక్షన్ ఫస్ట్ ఫంక్షన్ రెండు మెట్రిక్ స్పేసెస్ అయితే అడిషన్ ఆఫ్ టూ మెట్రిక్ స్పేసెస్ ఇస్ ఆల్వేస్ మెట్రిక్ ఆ రూల్
ఇక్కడ అడిషన్ టెక్నిక్ ఎందుకు వాడారమ్మా నాకు అర్థం కాలేదు. ఇక్కడ అడిషన్ లేదు కదా ఆప్షన్. లుక్ ఎట్ ద క్వశ్చన్ నెంబర్ 7. ఇక్కడ ఏంటి మోడ్ ఇచ్చాడు స్టెప్ ఫంక్షన్ ఇచ్చారు. ఇజ్ ఇట్ ఏ మెట్రిక్ అన్నాడు. సో ఇజ్ ఇట్ ఏ మెట్రిక్? యా, ఓకే. Okay. So question is that look at the second property. Is the symmetric true? Look, guess. Already I told you that mod is very, whenever is mod is there, almost symmetry property holds. So what is that? This is nothing but what? Step of modulus of x minus y. This is nothing but mod of x minus y is same as saying that mod of y minus x. But this is same as saying that mod distance between y comma x. So symmetric property holds. What about the third property? What about the third property? So what is my guess is that actually it may not be actually it may not satisfy the triangle inequality. Why? Because actually there is a step function. It is a restricted function, right? Whenever x lies between 0 to 1, it is 0. Whenever x lies between 1 to 2, it is 1. So there is some problem. It is restriction. So therefore, by guessing this idea, can you give 3 elements? This fails. Can you give me 3 elements in such a way that this inequality fails? So I can give x is equals to 2.2, right? Y is equals to suppose 1.2. My z is equals to suppose what is my actually what 1.8. 1.8. Z is equals to 1.8.
XY values more than a distance of 4-5 అట్లా స్టార్ట్ చేసుకుంటే ఫెయిల్ అవుతుంది సార్.
Right? Yeah, that's what my point. So what is my, so this is 1.8. So therefore, what is the distance between x and y? What is my distance between x and y? So this is nothing but what? Step of modulus of 2.2 minus 1.2. What is this? That is nothing but what? 2.2 minus 1.2 is nothing but mod 1. That is nothing but what? Is nothing but what? 1. Step of 1 is nothing but what? 1. So distance between x and y is 1. So what about distance between x comma z? Distance between x comma z is nothing but step of. So this is 2.2 minus 1.8. 0.4. Right? So mod of 0.4 is nothing but 0.4. Therefore, this is 0. Step of 0.4 is 0. What does it mean by distance between x and y? This is nothing but step of modulus of. What does it mean by distance between z and y? So what is this actually? 0.6. Right? So this is nothing but 0.6. This is nothing but 0. So distance between x and y is 1. But distance between x comma z is 0. Distance between z comma y is 0. Therefore, distance between x comma y is nothing but what actually? This is nothing but actually 1. 1 cannot be less than distance between x comma z plus distance between z comma y. Because it is 0, it is 0. This is right. Left side is 1, right side is 0. Sum is 0. Left side is 1, right side is 0. Therefore, it is does not satisfy the triangle inequality. See, what is my guess is that whenever step function is there, some restriction is there. We may guess that actually it is not a metric. We may guess. That is the idea. So therefore, this is not true. So is D a metric? Fourth option. Is D a metric? No, right? At least one of the condition failed. Therefore, it is not a metric. Right? D is not a metric. Answer yes, sir. Answer yes. D is not a metric. Okay, no? Answer
Yes, sir. Yes.
Yeah. Next question. Already we have seen this question. We have solved this question in lectures. Right?
Option 4 of the explain.
Hello?
ఏం చేస్తారు అక్కడ
ఆప్షన్ 4 మేడం మళ్ళీ ఒకసారి ఎక్స్ప్లెయిన్ ట్రయాంగిల్ ఇన్ఈక్వాలిటీ ఫెయిల్ అయిందంటే ఆటోమేటిక్ ఒక ప్రాపర్టీ ఫెయిల్ అయినట్టే కాబట్టి డి ఇస్ మెట్రిక్ కాదని చెప్తుంది.
Yeah, this is not a metric. This is not a
ట్రయాంగిల్
metric.
ఇన్ఈక్వాలిటీ ఫెయిల్ అయింది కదా సార్, 4 ప్రాపర్టీస్ లో ట్రయాంగిల్ ఇన్ఈక్వాలిటీ ఫెయిల్ అయిందంటే ఒక ప్రాపర్టీ ఫెయిల్ అయిందంటే ఆటోమేటికల్ గా మెట్రిక్ కాదు అని చెప్తుంది.
At least see already first condition
Second
fail
condition
now.
also
Second,
fails, sir.
yeah, second condition fail now. That's what my point. At least one of the condition fail now. Already triangle inequality failed. Second condition failed. At least one of the condition failed. That is not a metric, right?
సార్ యాక్చువల్గా క్వశ్చన్ అట్లా కదా సార్, క్వశ్చన్ ఏంటంటే నాకు తెలిసి సార్ది డి ఈజ్ నాట్ ఏ మెట్రిక్ అన్నాం కదా, అది కరెక్ట్ ఎట్లా అవుతుంది, అది రాంగ్ కదా అనే క్వశ్చన్. అది యాక్చువల్ మన క్వశ్చన్ ఫాలోయింగ్ స్టేట్మెంట్స్ ఆర్ ట్రూ అనేది కదా.
అవును. సో D is not a metric. D is not a metric అనేది ట్రూవే కదా మరి. D is not a metric అనేది ట్రూవే కదా అంటున్నా.
Yes, sir.
ఆయన అండర్స్టాండింగ్ అట్లా ఉందంటాడు.
యా అంటే ఇట్లుంటాయి క్వశ్చన్స్, మరి జాగ్రత్తగా ఉండాలి. అందుకే
నెగటివ్ క్వశ్చన్.
యా ఇట్లాంటి ఉంటాయి కాబట్టి కొంచెం జాగ్రత్తగా ఉండాలి మనం. ఇది పట్టున పట్టేసినాం అనుకో నెగిటివ్ మార్క్ వస్తుంది, ఆటోమేటిక్గా మనం మార్క్ పోతుంది. సో look at the question number 8. This is asked in CSIR NET 2013. So automatically this is a metric. We have shown that this is a very standard metric. Therefore it is a metric. Is it a metric? The answer no, right? The answer no, right? If you take x is equals to 2, see non-native there is no problem because modulus is there. X equals to 2, y equals to 1. What happens? Distance between 2, 1 is what? 2, 1 is nothing but 2 minus 2 plus. So 2 minus 2, that is nothing but what? 0. Distance between 2, 1 is 0, but 2 not equals to 1. Therefore, it is not a metric. X equals to 2, y equals to 1. Therefore, 2 minus 2, 2 minus 2. Therefore, 0. Therefore, distance is between 2, 1 is 0, but 2 not equals to 1. Therefore, fails to satisfy second property. We have shown that this is not a metric because n is even. N is even. Already I told you that when x power n minus y power n is metric whenever n is odd. Whenever n is odd, it is a metric. Here, what is what? What is n here? What is n? N is even. N equals to 2 is n. Therefore, it is not a metric. So here n is odd. N is odd. Therefore, it is a metric.
It's a metric.
So therefore, this is asked in CSIR 2013. Next. So this is also a very important question actually, or continuous functions. So when you have a continuous function actually, there are so many arguments are there. So this C01, what is that actually? Set of all real valued continuous functions defined on close 01 continuous function, right? The question is that is the answer first answer true or not? So the answer is that what is my distance function? Distance between f of f comma g is nothing but supremum of mod of f of t minus g of t. I come to this question later, but I want to solve this right now. The thing is that actually, you know, mod is always non-negative because f is see actually what is my function? My function is a real valued function, continuous function. It is a continuous real valued function. Whenever t is a real number, whenever t lies between 0 to 1, f of t is always a real number. So f of t is a real number, g of t is a real number, difference is real number, modulus is real number, supremum of non-negative is always non-negative. So D satisfy first property. There is no problem. Question is that does the supremum make this? Answer yes. Is it a real number? Is it a real number? Yes, the answer is because f is a continuous function, g also continuous function from close 0 1. So f minus g also continuous function. Difference of continuous function is a continuous function. When you go back to basic real analysis, f minus g is continuous function and a compact set. Therefore, f minus g attains bounds. It is bounded. F minus g is bounded. Whenever f minus g bounded and closed on 0 to 1 by completeness axiom, whenever it has a non-empty set which has bounded above, automatically supremum. That is a supremum in R. Therefore, the supremum exists. This is a finite real number, non-negative real number, right? Because f minus g is a continuous function and a compact set. Therefore, it automatically bounded. Once it is bounded, supremum exists. In fact, infimum exists. Okay, it is a real number. In fact, it's a non-negative real number. So second property also trivially true. Whenever distance between f comma g is 0, that means what? Supremum of f of t minus g of t is 0. That means what? T belongs to 0 to 1. Supremum is 0 means if and only each number sitting inside supremum is always 0 for every t. That means what? Whenever modulus 0, each member is 0 for each t. That means what? F of t equals to g of t for each t. That means what? F must be equals to g. That means both are equal function because whose domains are same, whose ranges are same. Therefore, they are equal functions. Converse also true, right? Converse also true. same stack, back. So therefore, automatically second condition hold. What is my third condition? Already I told you, whenever supremum, so mod of f minus g, same as saying that mod of g minus a, g minus f. Therefore, it is nothing but what? G comma f. Therefore, d of f comma g is same as saying that d of distance between g comma f. Therefore, it satisfies symmetric property. So what is the last property? Triangle inequality. So to prove the triangle inequality, how many functions do I need? I need 3 functions. Take 3 functions, continuous functions, real order continuous functions. Now what I do is that start with actually f of fixing for t belongs to close 0, 1. This is standard argument actually. Once you prove it, you understand. So f of t, adding and subtracting h of t. Oh, where is gone? Yeah. So g of t, this is by triangle inequality, f of t minus h of t plus h of t minus g of t. So this is one singular member. Singular member is always less than or equal to supremum of f of t minus g of t. Why this is true? Because supremum is always upper bound. Supremum is always upper bound, right? This is always less than or equal to h of t minus g of t over closed interval 0 to 1, right? So therefore, what is this? This is nothing but d of f comma h, this is plus d of h comma g. Therefore, what you observe is that distance between distance between f of t minus g of t is always less than or equals to distance between fh plus distance between h comma g. This is true for every t, because if you take any t, this is true. Therefore, this is an upper bound for the set over closed 0, 1. This is an upper bound for the set over closed interval 0 to 1, right? Over this set, right? So supremum of this set always least upper bound. Therefore, what is this? Least upper bound is always less than or equal to upper bound. This is at least one upper bound. This is what? So least upper bound. So least upper bound is always less than or equal to this. But what is this? D of f comma g. So triangle inequality holds. Therefore, it is a metric. This is standard metric already. So this is standard metric. When you want to read function analysis, you know this metric. This is a subnorm metric. This is uniform metric. Very standard maximum metric, uniform metric. Right? Next, uniform. When you replace already I told you uniform also exists. Did you understand this example? Put it in chat box. Did you understand?
Yes, sir. So we
Yes, sir.
already discussed a maximum function, minimum function.
Yeah.
I think these two are behave like that.
So therefore, this is true, right? Now second one, come to this. Already I told you f is a continuous function, g is a continuous function, difference is continuous function, mod is continuous function on a compact set. Therefore, it is a bounded function. Therefore, infimum exists. Infimum exists. This is non-negative. There is no problem with first property, right? So what is my second property? Is the second property true? Is the second property true? The answer, suppose you take f is equals to t, g is equals to 0. It's an identity function, always continuous function with respect to usual topology, usual metric. So therefore, this is always a constant function is always continuous function with respect to any topology, in fact, any metric. Therefore, f and g are continuous function. F and g are continuous function. Is it clear the step? Because f is a identity function with respect to usual metric. When you discuss the identity function, I tell you that this is always a continuous function. Identity function with respect to usual metric is always a continuous function, because f is a function from 0 to 1 to r. So whenever something is not given, you understand that it is usual metric with respect to. This is also usual metric. Usual metric is always a continuous function. This is also a continuous function. So f comma g is both comma g and both are continuous functions. But continuous function on a compact set. Therefore, infimum always exists for any two functions. But what about this distance between these two functions? That is nothing but infimum of f of t minus g of t over close 0, 1. That is nothing but infimum of what is f of t? T. What is g of t? Constant function 0. This closed interval 0 to 1. So you know that what is this? This is nothing but infimum of mod t over close 0, 1. You know that whenever t lies between 0 to 1, t lies between 0 to 1, t is non-negative. Therefore, mod of t is equals to t itself. Mod of t equals to t itself. Therefore, what is the infimum? Infimum of the set. This is a line passing through origin y equals to t. What is the infimum? Infimum occurs at 0 over closed interval 0 to 1. Infimum occurs at 0, 1, right? So therefore, what is infimum? 0. So therefore, distance between f comma g is 0, but but f not equals to g, because f is a identity function t, g is a constant function 0. Therefore, f of 1 is equals to 1, g of 1 equals to 0. Therefore, f of 1 not equals to g of 1. Therefore, these are not equal functions. These are not equal functions because f of 1 not equals to g of 1. Why? Because if g of 1 is 0, f of 1 is 1. Therefore, they are not equal functions. Therefore, it fails to satisfy the second property. Therefore, it is not a metric. Supremum of the continuous function is always a metric, but infimum of that modulus of f minus g is always is not a metric on space of all real valued continuous functions on closed interval 0 to 1. Is it clear?
Yes, sir.
Yes. So this is also standard metric. This is nothing but L1 metric. So I'm going to prove it. These are the standard metric actually. Right. So these are the standard metrics. So it takes time actually. Once you prove it, then you can directly take the answer. First time we need to write, we need to prove the result. So what you do is that, what is this actually? D of f comma g is nothing but integral 0 to 1 mod of f of t minus g of t dt. This is L1 metric. So what is this actually geometrically means? Actually, I tell you later actually geometrical idea. But to prove this question, you know that what is my f? What is my f? F is a continuous function. What is my what? F is a continuous function. Right? What is my g? Continuous function. So f minus g is always continuous function. So any continuous function always Riemann integrable. Modulus of the Riemann integrable is always Riemann integrable function. So this integral is a real number. Yes or no? Because f minus g is a continuous function. Any continuous function is a Riemann integrable function. Mod of the Riemann integrable function is always Riemann integrable. Therefore, this is a finite real number. In fact, this is non-negative. This mod is non-negative. Integral is non-negative. Therefore, it is non-negative real number. Is it clear the first step? Put it in chart box. Is it clear the first step? Due to the continuity, it is Riemann integrable. Therefore, this integral is meaningful. Integral of the function may not be defined actually. Integral may not define for all functions. For example, if you take 1 by x, Riemann integral does not exist. Understand? We can check for the improper integrals. Right? This integral does not exist because it fails to, its function is not bounded at 0 over closed interval 0 to 1. So therefore, this function doesn't have a Riemann integrable, right? So therefore, it is not Riemann integral function over closed interval 0 to 1. Therefore, we go for the improper integral. Right? So that's what here why there is no problem, because actually f is a continuous function, g is a continuous function, there is no problem. Right? Next, d of f comma 0, second property. You know what is this? Integral 0 to 1 mod of f of t minus g of t. This is d of dt equals to 0. So integral of the continuous function. In fact, there is a very standard inequality, standard result. Integral of the continuous function is 0 if and only if the function is 0 whenever the function is non-negative. Whenever the function is non-negative, right? Here this mod function is there. Here mod function is there. In fact, inside function is continuous. So continuous function, mod function is there. Therefore, non-negative continuous function, whenever the integral is 0, the integrand must be 0. Right? So that means mod is 0 if and only if f of t equals to g of t for every t. That means f equals to g. So converse is directly. Converse also directly. No need to prove it directly. It's straightforward. Is it clear the step? Put it in chat box. Is it clear?
Sir,
Is it clear?
small doubts.
Yeah. Your voice is not audible. Your voice is not clear.
సార్ క్వశ్చన్ ఎక్స్ప్లెయిన్ చేస్తారు కదా సార్. సో కొన్ని కీ పాయింట్స్ ని మాకు నోట్స్ లో ఇస్తే బాగుంటుంది సార్. అది క్వశ్చన్ ఎక్స్ప్లెనేషన్ లో బాగా అర్థమవుతున్నది, కానీ పాయింట్స్ వైజ్ కొన్ని ఏమన్నా ఇస్తే బాగుంటుంది అనిపిస్తుంది సార్. నెక్స్ట్ సేమ్ మోడల్ క్వశ్చన్ గా ప్రిపేర్ కావడం. అంటే
ఏంటి నాకు అర్థం కాలంటే పాయింట్స్ రాసి ఇవ్వాలా?
అంటే నోట్స్ రూపంలో ఇవ్వలేకపోతున్నారు కదా.
నోట్స్ ఇస్తారు, మీకు నోట్స్ ఇస్తాడు, వస్తారు, డెఫినెట్ గా ఇస్తాము.
సో మీరు క్వశ్చన్ ఎక్స్ప్లెయిన్ చేస్తుంటే ఎవ్రీథింగ్ విల్ అండర్స్టాండ్ సార్. మళ్ళీ సేమ్ అదే క్వశ్చన్ మనకు వచ్చినప్పుడు కొంచెం ఆ పాయింట్స్ రికాల్ చేసుకోవడానికి ఇట్లా ఏమన్నా
డెఫినెట్ గా మీకు ఇస్తాం సార్. మీకు ఇస్తాం, డెఫినెట్ గా నోట్స్ అనేది ఇస్తాం.
ఓకే ఓకే సార్.
బట్ థింగ్ ఏంటంటే మీకు ఇది అర్థమైందా సార్? ఇది అర్థమైందా? ఇజ్ ఇట్ క్లియర్?
ఓకే సార్, అర్థమైంది సార్, అండర్స్టాండ్ సార్.
సార్ పాసిబిలిటీస్ ఉంటే నువ్వు అన్నట్టు కొన్ని కీ పాయింట్స్ కానీ ఈ ప్రాబ్లమ్స్ కానీ రాసే ప్రయత్నం చేస్తాం సార్.
ఈ క్లాస్ తర్వాత మీకు షేర్ చేస్తాను నోట్స్, ఎందుకంటే ఈ క్లాస్ తర్వాత, ఎందుకంటే ఈ ఒక్క క్లాసు ఈ నోట్ వన్ నోట్ లో వేరే వన్ నోట్ లో ఉంది. ఇది కంటిన్యూషన్ చేసిన తర్వాత నెక్స్ట్ క్లాస్ నుంచి మీకు ఎవ్రీ క్లాస్ మీకు షేర్ చేస్తాం.
ఓకే ఓకే సార్,
నోట్స్ షేర్ చేస్తాం.
f f comma g is equals to what is my triangle inequality? You know, there is a modulus, there is no problem. This is nothing but what? Integral mod of g of t minus f of t. Therefore, symmetry property, there is no problem. What about the triangle inequality? Triangle inequality is nothing but what? You start with three functions, three continuous functions, right? F of t minus g of t dt, right? So this is nothing but 0 to 1 f of t minus adding and subtracting f of t h of t. So therefore this g of t dt. You know, triangle inequality using this modulus. So what is this? What is this? This is nothing but f of t minus h of t plus h of t minus g of t, right? So integral of the sum is equals to sum of the integral. You know that in basic real analysis, in Riemann integration, integral of the sum is always sum of the integral. So this is nothing but d of f comma h. This is d of h comma g. So triangle equal to default. So therefore it is a integral. Is it clear? Is it clear this step?
Yes, sir.
Okay. So therefore,
దీన్ని రఫ్ చేయకుండా ఇదే రఫ్ మనం యాక్చువల్గా పంపలేమా సార్?
ఇది ఈ పేపరా సార్?
ఈ పేపర్ సైడ్ కి చేశారు కదా, అవసరమైతే కొంచెం కిందికి చేసేసుకోండి.
అయితే ఇది కట్
యాక్చువల్గా మనం ఆ క్వశ్చన్ వైజ్ స్క్రీన్ షాట్ తీసుకుంటూ వస్తుండదు సార్. ఇక్కడ ఎక్స్ప్లెనేషన్ కంప్లీట్ అవగానే స్క్రీన్ షాట్ తీసుకుంటే మనకి అట్లా పేరు ఉంటుంది. నోట్స్ నీట్ గా రాసుకోనికి ఒక అవకాశం ఉంటుంది మనకి.
అట్లా చేయండి సార్, ఎవరైనా అట్లా కావాలనుకున్నప్పుడు.
ఈ ఒక్క క్లాస్ మందం ఈ క్వశ్చన్ పేపర్ మందం అట్లా చేయండి సార్. నెక్స్ట్ నుంచి మీకు పంపిస్తాం, ఎందుకంటే ఇది ఒక్కటి 2010 చెప్పాను కదా సార్. ఓకే సార్. So what is my next one? Yeah, this is a metric. Okay, is it a metric? Fourth one?
Yes, sir. Yes, sir.
Because it is a sum of two metrics. This is a metric. This is a metric we have seen. This is first option. This is a metric. We have seen that this is a metric. This is a third option. This is a metric. Sum of two metrics is always a metric. Therefore, it is a metric. Right? So what is the answer? A, C, D. Is it clear?
Yes, sir.
Yes. Already I told you, whenever something metric inside, you know, this is a convergent series. So X is a set of all real sequences. X is a set of all real sequences. What are the members in X? Real sequences. Each term is a real sequence. You know, this is a metric. You know that. Already we know that this is a metric. This one is a metric. Yes or no? This one is a metric. So therefore, this is a metric. And this series is convergent. You know, summation n equals to 1 to infinity. 1 by n square is always convergent by p test, because p equals to 2, which is bigger than 1. It is always convergent. So already I told you in previous problem. So therefore, whenever this is metric, something which is a convergent series always a metric. Yes or no? Put it in chat box.
Sir, ఒకసారి రిపీట్ చేయరా?
ఇంతకుముందు మీకు ఏం చెప్పానమ్మా? సమ్మేషన్ i ఈక్వల్స్ రికాల్ చేసుకోండి. ఒక ఎగ్జాంపుల్ కంపేర్ చేయండి. సో దర్ఫోర్ ఇంతకుముందు ఇట్లాంటి కన్వర్జెన్స్ p such that xi minus yi
కన్వర్జెంట్ సార్. ఇక్కడ కామా 1 మినిమం ఆఫ్ x కి y కి కామా 1 సార్. అది
కామా 1 మీ దగ్గర మీకు స్లైడ్ మీకు ఇచ్చాను, ఈ నోట్స్, ఇది ఈ క్వశ్చన్ పేపర్ మీకు ఇచ్చాను. ఇది కామా 1. ఇది ఆల్రెడీ మెట్రిక్ అని మనం చేసాం, గుర్తుంది కదా? ఓకే, దిస్ ఇస్ మెట్రిక్ ఆల్వేస్ whenever k is positive. We have done it yesterday. Whenever k positive, this is always a metric.
Yes, sir. Right? Minimum, maximum time.
Not maximum. Maximum is not metric. Only minimum is a metric.
ఆ టైం లో చెప్పారు మీరు.
Yeah. So therefore,
maximum function metric అవుతుంది, minimum function metric అవ్వదని డిస్కస్ చేసాం సార్. ఎందుకంటే సెకండ్ కండిషన్ ఫెయిల్ అవుతుంది చూడండి. x y not equal to
అవుతుంది. No. Minimum is a year. Minimum is standard metric.
In yesterday's class.
ఏంట మేడం?
మినిమం ఇస్ మెట్రిక్ అని చెప్పారు సార్ yesterday's class లో.
Yeah, this is a metric. That's what my point.
Yes, sir.
So this is a metric. This is a metric. This is a convergence series. For the previous problem, whenever it is a metric, whenever this is a convergence series, always this is a metric. Yes or no? Is it clear? Is it clear?
Yes, sir.
సార్ అది కొంచెం కన్ఫ్యూజ్ అవుతుంది సార్. ఏంటంటే ఎక్స్ ఇస్ ద సెట్ ఆఫ్ రియల్ సీక్వెన్సెస్ అయినప్పుడు ఒక
Okay, నేను
కండిషన్
prove
ఉంది. ఎక్స్ ఈక్వల్స్ టు ఆర్ ఉన్నప్పుడు రివర్స్ లో ఉంది కదా.
ఓకే, ఒకసారి చూడండి, నేను చెప్తున్నాను. మీరు కంపేర్ చేస్తే మీకు కొంచెం ఈజీగా ఉంటుంది. ఓకే, ఎనీబడి. ఓకే, ఎనీవే ఐ విల్ ప్రూవ్ ఇట్. సేమ్ స్టెప్స్ కదా, మళ్ళీ చేయడం ఎందుకని చెప్పట్లేను అంతే. దట్స్ ఇట్. ఇగో ఇది ఆల్రెడీ చేశాను చూడండి ఇక్కడ. సేమ్ లైన్స్. ఎక్స్ ఏంటి అక్కడ కూడా సెట్ ఆఫ్ ఆల్ రియల్ సీక్వెన్సెస్ ఇన్ ఆర్. రైట్. ఫస్ట్ మీరు అబ్జర్వ్ చేయాల్సిన విషయం ఏంటంటే దిస్ ఇస్ ఆల్వేస్ ఏ మెట్రిక్. మినిమమ్ ఆఫ్ 1 minus xk minus xi minus yi or xk minus yk is always a metric for every k, for every k equals to 1 to 3. Right? This is always a metric. Yes or no? ఇది మీకు తెలుసు కదా. Minimum of something
Yes.
a comma any metric inside is always a metric whenever k a positive. Yes or no?
Yes, sir.
This is true for అంటే k equals to 1 పెడితే ఒక మెట్రిక్ వస్తుంది, k equals to 2 పెడితే ఇంకో మెట్రిక్ వస్తుంది. Therefore there are countable metrics. Once it is a metric, now what I do is that already what you are given, there is some k term is there. This is, this is minimum is always bounded by 1 because k is 1. Here k equals to 1. Therefore this is bounded by 1. So 1 by k square, you multiply with k square on both sides. Right? The inequality doesn't change because k square is positive. Right? So therefore this series always less than or equals to this series. By comparison, by p test, this is always convergent because summation n equals to 1 to infinity. 1 by n square is always convergent by p test. P equals to 2, which is bigger than 1. Whenever this is convergent, by comparison test, this is convergent. That means what? D of x comma y is convergent. That means what is finite. అర్థమైందా?
Yes sir.
ట్రయాంగిల్ ఇన్ఈక్వాలిటీ సేమ్ అమ్మా. ఇంతకుముందు ఎట్లా చేశారు అట్లే చేయాలి. చెప్పాలా? అవసరం లేదు. టైం ఇవంతా ఎంత గుంజుతూ ఉంటుంది. రైట్, దట్స్ ఇట్.
No
ట్రయాంగిల్
next.
ఇన్ఈక్వాలిటీ సేమ్. ఇంతకుముందు మనం చేసాం కదా ఫస్ట్ ప్రాబ్లం కి, అదే ఆర్గ్యుమెంట్. ఇస్ ఇట్ క్లియర్?
Yes sir.
Yes. Okay. So therefore, next one. Yeah, it's one. Okay. Question is, it's a metric. Once it is a metric, first condition, this is true because d of x comma y is 0. The points are coincident whenever x is a metric. X is a metric space. So this is also true because d satisfies symmetric property. Why? Because d is a metric. D is a metric means what? Second, this condition also holds symmetric property. This is a triangle inequality. This condition also true. D is not a metric. Is it true? D satisfies all conditions actually. Is this
No,
not
sir.
a metric? No. So this is wrong. So what are the answers? A, B, C. Is it clear?
Yes, sir.
Yes. So this is also a very, very important problem, but this is a lengthy problem. Okay, this is a lengthy problem. I'll prove one case. In one case. Okay, this is also asked in GATE question. The lengthy problem. Triangle inequality is a lengthy problem. Okay. So what is my question actually here? D of x comma y is, so what is my set? Set is nothing but real numbers. Mod of x minus y plus 1 if x is positive or y is positive. At least one of them is positive. At least. Not both positive, not both positive. Either x positive or y positive. That's it. Otherwise, mod of x minus y. Understand? So this is my set. Question is that, see, mod is always non-negative. Non-negative plus 1 is always positive. So this is total positive. This is non-negative. Already I told you. So this is non-negative. Adding 1 on both sides. This is nothing 1. This is nothing but 1. 1 is positive. Therefore, this is positive. So this piece is always positive. Right? This one is always positive. Yes or no? This one is positive. So this is positive. This is non-negative. This is non-negative. So positive, non-negative. Therefore, what is a Final argument, this is non-negative for all x comma y belongs to R. Therefore, first condition is true. Therefore, first condition is true because this is positive, this is non-negative. Therefore, overall, this is non-negative. Is it clear the first step?
Yes, sir.
Yes, sir.
Yes. Suppose if x equals to y, I want to show the second result. Suppose if x equals to y, I want to show that d of x comma y is 0. But if x is equals to y, what happens? If x is equals to y,
1.
no. If x is equals to y, what is the condition you are given? You are given that, see, whatever condition you are given, you need to work with the condition. In all times, the same things will not work out. Understand what you are given, you need to work with the only given
Correct.
conditions. So here x positive, y positive. Whenever x and y are two real numbers which are equal, what are the possibilities? Either x positive, y positive, x negative, y negative, x is equals to, understand, x negative, x positive, y negative, this is negative, this is positive, right? So whenever x and y are equal, x and y should have the same sign, right? We should have the same sign. Yes or no? Whenever x and y are should have the same sign, what is our metric? What is my function? See, what is in this case? This case, whenever x is positive or y is positive, one can take this function. Or else you can take this function, mod function. Whenever x is positive or y is positive, you can take this first function. Whenever x is other, or else you can take this function. Here x positive means automatically y positive. That means what? Don't take this condition. If x is negative means y also negative. Therefore, don't take this condition. So first condition is not you're not taking the first condition. So what you do is that you need to take the second option, mod of x minus y, because the first option is applicable for whenever x is positive or y is positive. Understand? Therefore, this is nothing but mod of x minus y. But x is equals to y, you know that. Therefore, x minus x, that is nothing but 0. Is it clear the step?
Sir, here 4 possibilities are there, no, sir. Two
That's-
positive, 2 negative, and alternative positive and negative.
That's what my point, madam.
Yes.
See, the thing is, whenever x equals to y, these are omitted. Why? Because whenever x equals to y, the signs are same, right? Whenever x is positive, y should be positive. Y should not be negative, right? Because both are same. So these options are omitted. You need to exclude these options. So take these two only. These two are only applicable. Yes or no? Whenever x and y are, see, x equals to y means what? X equals to y means what? 1 equals to 1. Minus 1 equals to minus 1. Right? Both should have the same sign. That's what my point. Whenever both should have same sign, so you can take this option. Therefore, distance is 0. Is it clear? Okay. So what is my second one? Distance equals to, you're given that actually this is nothing but mod of x minus y plus 1. You're given that actually another option is this is mod of x minus y. This cannot be 0. You know that this cannot be 0. This is always positive. We have seen so many cases because this is non-negative. This plus 1 is always positive. So what is my second option? When you take distance is 0, you need to show that x equals to y. What is our aim? Our aim is to show that x equals to y. So distance is 0. This is not our case. So what is our case? Mod of x minus y. Therefore, mod of x minus y equals 0. That means what? X equals to y. We have done it. Is it clear? Is it clear? This is not our case. When you take the distance comma x comma y equals to 0, what is the distance function? Mod of x minus y plus 1 is not occurred because it is positive. It is non-zero. Therefore, don't consider this case. You need to consider only this case because distance is 0 whenever distance between x comma y equals to mod of x minus y. Is it clear?
Yes, sir.
Yes.
Yes, sir.
So we have done two cases. So symmetry property is redundant. Symmetry property is redundant. Whatever case you take, actually nothing wrong because modulus is there now. So there is no problem. This is nothing but mod of x minus y or else. So this is nothing but mod of y minus x plus 1, this condition, mod of y minus x, this condition. This is nothing but d of y comma x. So symmetry property is redundant because modulus is there. Is it clear?
Yes, sir.
Yes, sir.
So triangle inequality, what I do is there are so many options, Amma. So I want to try only one method, one case. Remaining steps are same as it is. So I want to show the triangle inequality. Right? Start with 3 real numbers. So what are the possibilities? There are so many possibilities, either x0 positive, x negative, y0, y positive, y negative, z0, z positive, z negative. So I want to take one condition. If you take x equals to 0, case 1, the same proof is applicable for all cases. If you take x is equals to 0, what is my distance function? What is my distance function? Distance function is, so what is my distance function? What is my distance function? 0 minus y plus 1 if y is positive. Yes or no? Is it clear? These are the standard metrics. These are the standard metrics. Is it clear, Rama? Is it clear? At least one of them is positive. You take the
Yes,
first
sir.
option, na? At least one of, see, at least means what? One of them is positive, not at least one of them is positive. Here y is positive, therefore, this must, you need to take the first option. What is my second condition? If you take y equals to 0, what is that? If you take y equals to 0, that means what? x0, y0. What is your option? You need to take second option. You need to take second option, right? If you take y is negative, what is your option? Here x is not positive, y is not positive. One of them is not positive. Therefore, what is your option you're taking? What is your option you're taking? 0 minus y. Is it clear? Is it clear the step?
Yes, sir.
Yes. This can be rewritten as mod of y plus 1 if y is positive. This is nothing but what actually 0. That means what? That means what? Mod y. Because I'm assuming that y. Therefore, this is nothing but what? Mod y if y is less than or equals 0, because this can be replaced by y now, because y equals to 0. So in both cases, mod y equals to mod minus y, right? Both are same. Yes or no?
Yes, sir.
So therefore, I need to take the triangle. I need to show the triangle inequality. I need to consider only first option, because there are long options. Therefore, I want to show that only one case. Take distance between x comma y is equals to mod of y plus 1 whenever y is positive. Y is positive, x is 0. Yes or no? So what I do is that adding and subtracting z, because I need to show the triangle inequality. I need to show that triangle inequality. Adding and subtracting z, right? So by triangle inequality, this is nothing but mod of y minus z plus mod z plus 1. By triangle inequality, because x and y are the real numbers, y z are also real numbers, right? So here y is positive. Y is positive. One of them is positive. So what is our metric? Y minus z plus 1. You keep this as a in a bracket. This is mod z. Yes or no? Yes or no? Is it clear?
Yes.
Yes. So therefore, see, there are two options again. Z can be positive, Z can be 0. Yes or no? There are three options. Z is positive, Z is negative, Z is 0. See, this is a very long proof. So Z is positive means if you take Z is positive, what you do? Y positive, Z positive. Y positive, Z positive. So what you do? You need to take Y minus Z plus mod Z plus 1. You need to consider this. I'm considering Z positive, Y positive, X equals to 0. I'm considering Z positive, Y positive, X equals to 0. Right? So therefore, whenever X and Y and Z are positive, what is this actually? D of Y comma Z. Yes or no? Both are positive means second case. One of them is positive means what? First case. Yes or no? Is it clear?
Yes, sir. Yes, sir.
So plus, this can be rewritten as 0 minus Z plus 1. But this can be rewritten as YZ plus what is 0? You know that actually this is X. Right? So here Z is positive. You know that here Z is positive. Therefore, what is this? What is this? Second one. This D of Y comma Z plus D of X comma Z. Understand? So triangle inequality holds. In which case Z positive, Y positive, X is equal to 0. Similarly, one can show these, all these things. Is it clear? I hope you understand.
Yes, sir.
You need to show all the cases. This is an exercise. Okay. I show one case. You need to show all cases. Therefore, it is a metric. It's an exercise. Treat it as an exercise. Therefore, it is a metric. Therefore, once it is a metric, this condition hold. Once it is a metric, symmetric property hold. Symmetric property holds. Once it is a metric, triangle inequality holds. D is not a metric. Is it right? No. So triangle inequality true, and symmetric property true, and non-negative property is true. Therefore, A, B, C are the right answers. Is it clear, Amma?
Sir, here in this question we are checking for metric, right, sir? Because question में mention नहीं है कि metric है कि नहीं.
Yeah, these are the conditions, na metric conditions, na. These are the metric conditions. You need to check it. See, already yesterday I have given worksheet. Have you worked or not? Look at the questions.
No, I understood, sir. If the question same like come in the exam, they nowhere else mentioned that which is true, which is false, which is metric. Like nowhere else mentioned.
Yeah.
In such a case, we need to find out that metric case only, not metric case.
Yeah. Here actually, which of the following is not which of the following is not true, which of the following is true, they are not mentioned. But you need to understand that which of the following is which of the following options are true. You can assume that. You can assume that.
Yes.
Yes or no? So question actually it is not proper, right? Yes or no? According to option.
Yes.
No? Yes. Okay. Yeah, this is an important question. Again, this is also important question, right? See, what is your space? Look at your space first of all. Riemann integral functions, right? Riemann integral functions. What is your space? Set of all Riemann integral functions over AB, over bound closed and bound interval AB, right? Is it a metric? Is it a metric? So first you need to check the non-negative property. Here modulus is there. Mod of the integral function is always non-negative. There is no problem with first condition. Right? Because f is integrable, g is integrable, f minus g is integrable, mod is integrable, mod is non-negative, therefore integral also non-negative, therefore d of f comma g is non-negative. First option is redundant, Amma. First option is redundant, right? What is the second option? If you take f equals to g, distance between f comma g is always 0, right? Because this is f of t minus f of t dt, this is cancelled, therefore integral of 0 is 0. So whenever f is g, distance is 0. So this option also true. What is converse? Is the converse true? If d of f comma z 0, does it mean that f equals to z? Does it mean that f equals to z? The answer need not be. This is important question. So therefore, why? What can you give example? I can give an example. So if you take this one, 1 a less than x less than or equals to b, 0 discontinuous function at finite many points. Because I need a Riemann integral functions now. I need Riemann integral functions. So you need to take two functions which are Riemann integrable, whose distance is 0, but the functions are different. Understand? Because I need to see in which space you are working on a Riemann integral functions. So you need to take two functions which are different, which are Riemann integral function, which are distinct, but which are whose distance is 0. Whose distance is 0. You need to find at least two Riemann integral functions which are distinct, but whose distance is 0. Right? So you need to take this is b. So this is clearly Riemann integral function because it is discontinuous at only one point. It is a constant function over a to b. It is x is equals to b. It is 0. So it is discontinuous only at b. Only at b. So there is a standard result. F is Riemann integrable in root-in if f is discontinuous. When you go through the real analysis, you know this argument. Discontinuous at finitely many points. Finitely many points. ఒకవేళ ఫైనైట్లీ మెనీ పాయింట్స్ దగ్గర ఎఫ్ డిస్కంటిన్యూస్ అయితే ఆటోమేటిక్గా రిమాన్ ఇంటిగ్రల్ అవుతుంది. ఇక్కడ ఓన్లీ బి దగ్గరనే డిస్కంటిన్యూస్ అవుతుంది, మిగతా దగ్గర కంటిన్యూస్ ఫంక్షన్, ఎందుకంటే ఇది కాన్స్టెంట్ ఫంక్షన్ కాబట్టి ఆటోమేటిక్గా రిమాన్ ఇంటిగ్రల్. దేర్ఫోర్ ఎఫ్ ఇస్ రిమాన్ ఇంటిగ్రల్ ఫంక్షన్. ఐ వాంట్ టేక్ అనదర్ వన్, g to be constant function. Right? Constant function is always Riemann integral function because constant function is always continuous function with respect to topology. Therefore, this is also Riemann integral function. Therefore, f and g are Riemann integral function. What is the distance? What is the distance? 0 a to b, f of t. What is f of t? 1 minus 1 dt. Right? So this is nothing but integral of 0 is nothing but 0. So distance is 0, but the functions are different because f at b is 0, g at b is constant function 1. So f of b not equals to g of b, therefore f not equals to g. Whose distance is 0, but f not equals to g. Therefore, it is not a metric. So second condition fails. What are the options you are given? What are the options you are given? D is a metric. Is it true? No, because second condition failed. Yes or no? D of f comma g equals to 0. Distance is 0. That will imply f equals to 0. No, we have shown. Right? distance is 0, we have shown that distance is 0, we have shown that f naught equals to z. So therefore, the second option is false. D is not a metric. Yes or no? It is always true. D is not a metric. It is always true.
Yes, sir.
If f equals to z, distance is 0. This is right. We have shown. We have shown that if f equals to z, distance is 0. So therefore, this is the option. Right? Next.
Shall we take 5 minutes break, sir?
Sir, 2 questions ఉన్నాయి అయిపోతాయి సార్. 2 questions చెప్తే
Okay,
అయిపోతాయి.
carry.
2 questions చెప్తే మొత్తం CSIR questions అన్నీ.
Yeah, carry.
So ఇది ఆల్రెడీ మీకు చెప్పిన ఆర్గ్యుమెంట్ ఏమో. సో వాట్ ఐ టెల్ యూ ఇస్ దట్, సో లుక్ ఎట్ దిస్ ఆర్గ్యుమెంట్. లుక్ ఎట్ దిస్ ఆర్గ్యుమెంట్. మీ స్క్రీన్ షాట్లు తీసుకున్నామా, ఇది ఒక్క క్లాస్ మందం, ఎందుకంటే యాక్సెప్ట్ చేయట్లేదు 1 నోట్ కాబట్టి. సో దర్ఫోర్ see what is your given. You are given that d1 is a metric on x. What you are given, d1 is a metric on x, right? So what are the question? Then choose the correct statements. There exists a metric d2 on x such that whose distance is bounded by 1/64 for every x comma y belongs to x. There exists a metric d2 which is a bounded metric which is bounded by 1/64. Is it true? There exists a metric. Can you give a metric which is bounded by 164 by using d1? The answer yes. I can define d of x comma y is equals to minimum of 1/64 comma d1. You know it is a metric because d1, this is 1 by k equals to my k equals to 1/64. Therefore it is positive. Therefore it is a metric because d1 is a metric. K is positive. Therefore it is a metric. Is it bounded by 64? Yes, it is bounded by 64. Therefore there exists a metric d2 which is bounded by 1/64. So first option is true. Is it clear? Is it clear? There
Yes,
exists అన్నాడు ఫర్ ఎవ్రీ అన్లెస్ there exists a metric. ఇవ్వగలుగుతాం ఎందుకు మినిమం ఫంక్షన్ ఉంది కదా మనకు చేతిలో. మినిమం ఆఫ్ k కామా d where k is positive, always bounded metric. Therefore this is true. There does not exist a metric d2 which is bounded by 1/64. There does not exist at all. Right? This is absolutely wrong. We can define a bounded metric which is bounded by 64. Is it true? For every n, can you find a metric d2 which is bounded by 1/3 power n? The answer is give me n. What is the question? Give me n. Can you find a metric d2 which is bounded by 1/3 power n? The answer yes. Again same argument. D is equals to, what is my d? My d is equals to minimum of 1/3 power n comma d1. You know 1/3 power n is positive. Therefore it is a metric. This is bounded by 1/3 power n. Yes or no? So we can find a metric d2. We can find a metric d2 which is bounded by 1/3 power n. This is true for every n. మీరు ఏ n ఇస్తే ఇది ట్రూ అయితేనే ఉంటుంది. మీరు ఏ n ఇచ్చినా, మీరు n equals to 1 ఇస్తే నేను 1/3 ఇస్తా. మీరు n equals to 2 ఇచ్చారనుకో నేను 1/9 ఇస్తా, 1/3 square. So this is always a metric. Is it clear, Amma? Yes.
Sir, yes.
So fourth option, look at the fourth option. For each n, there does not exist a metric which is bounded. There does not exist a metric d2 which is bounded by 1/3 power n. Not right, right?
Not right.
Is it right?
No.
So A, C are right. D is false. So 14th question, x comma d is a metric space. Define a new map d1. D1 is equals to minimum of k comma d of x comma y, where k is a fixed real number. K is a fixed real number. So which of the following are correct? Okay. D1 is a metric. What is my D1? D1 is nothing but minimum of 1 comma d. So minimum of k comma d. If k equals to 1, is it a metric? Yes. If k equals to 1, k is positive, therefore it is a metric.
Second answer.
Right? It is positive, therefore it is a metric. So D1 is a metric if k1 bigger than 0, bigger than 1. Yes. If k bigger than 1, automatically positive. Therefore k positive means automatically it is a metric. Yes or no?
Yes.
Yes, sir.
What about the third option?
No.
D1 is a metric if k less than 1. No, right? If I take k equals to 0, what happens? If I take k equals to 0, what happens? So minimum of, if you take k equals to 0, 0 comma d of x comma y. If k equals to 0, this is a 0 function, constant function, it is not a metric. Therefore, if k less than 1, need not be metric. Right? So this A right, B right, C is not right. Question next, C, D. Look at the option D. D2 is equals to D plus D1. Right? D equals to D plus D1. Then D2 is a metric only if k bigger than or equals to 1. D2 is a metric. See, know that D1 is a metric. Already, see, D is a metric already you're given. D is a metric already. D is a metric already you're given. What is D1? D1 is equals to minimum of K comma D. So when do you say that D2 metric? When do you say that D2 metric? Whenever D1 metric, D1 plus D1 is always a metric. So D2 is a metric. D2 is a metric. Metric on X. If and only D1 is a metric. Yes or no? Right? When do you say that D1 metric? So already they are mentioned that D2 is a metric if K bigger than or equals to 1. Is it true? Only bigger than or equals to 1. Yes or no? No, right? Because if I take K equals to 1 by 2, if I take K equals to 1 by 2, it is positive now. So when I understand, it is positive now. So therefore D1 is a metric. Yes or no? So only this is wrong. Understand? D2 is a metric. If K bigger than 0, that is right answer. If K bigger than 0 is the right answer. If only K bigger than equals to 1 is wrong. Only K bigger than equals to 1 is wrong. Because I can choose K equals to 1 by 2, which is positive, which is big, which is less than 1. So therefore in this case also, it is metric. But what is the option? D2 is metric only if K bigger than equals to 1. It's wrong. Yes or no? Is it clear? Is it clear?
Sir, explain fourth option again.
See, D2 is equals to D plus D1. Yes or no? Already D and metric on each side. Yes or no? D2 is a metric. D is a metric on X. When do you say that D2 metric? When do you say that D2 is metric? D1 must be metric.
In the condition, it is K greater than or equal to.
D must be metric. Yes or no? D2 metric if D1 must be metric. When do you say that D1 metric? D1, what is D1? D1 is nothing but minimum of K comma D. Yes or no? So when do you say that D metric? K positive. But మనకి ఇక్కడ ఆప్షన్ ఏమి ఇచ్చాడు? K bigger than equals to 1 అయితేనే మెట్రిక్ అని ఇచ్చాడు. కాదా? తప్పు కదా? ఓన్లీ K bigger than equals to 1 ఇచ్చాడు. చూడండి ఇక్కడ. ఓన్లీ K bigger than equals to 1 ఇచ్చాడు. So answer wrong. So D2 is a metric.
K greater than 0 is correct, sir.
Yeah, K bigger than 0 is a right. But ఇక్కడ K bigger than ఇక్కడ ఓన్లీ లేకపోతే రైట్. ఓన్లీ లేకపోతే రైట్ అమ్మా. D2 is a metric if K bigger than equals to 1 right. But only అనేది తప్పు అంటున్నా. అర్థమవుతుందా?
సార్ ఇక్కడ మంచి పాయింట్ అది. అడిగింది కూడా ఓన్లీ అనే పదం లేకపోతే అది కూడా ఆప్షన్ తీసుకోవచ్చు. అది
ఆప్షన్ కరెక్ట్ తీసుకోవచ్చు. అదే అంటున్నాను సార్.
గుడ్.
యా ఓన్లీ అని అందుకే చెప్తున్నాను ఆప్షన్ పర్ఫెక్ట్ గా చూడండి. ఆప్షన్ చూడకుండా ఆన్సర్ పెడతా మాత్రం ఫినిష్. Is it clear, Amma? All of you? All of you, is it clear?
Yes.
Yes. So what is the last one? This is asked in CSIR recent question paper 2020. These are all recent question papers. Okay. So 2020. So what is my function? What is my function? My function is right. So my function is this. Is a function of two variables. It's a real valued function. Function of two variables. P of x comma y is mod x if x is non-zero, and mod y if x is 0. Right? So ఇక్కడ మీరు ఆప్షన్ చూడండి. మెట్రిక్ అని ప్రూవ్ చేయడం కాదు. ఆప్షన్స్ ఏమి ఇచ్చాడో అది చూడండి. విచ్ ఆఫ్ ద ఫాలోయింగ్ స్టేట్మెంట్స్ ఆర్ ట్రూ? ఇదే చేయండి. మెట్రిక్ అన్నాడు కానీ అన్ని మెట్రిక్ చేయదు. రైట్? ఇది మెట్రిక్, ఇది డిస్టెన్స్ ఫంక్షన్ ఏమి వేయలేను ఇక్కడ. r square p is a function from r to r square defined by like this. So look at the first option. What is my first option? P of x comma y 0 if and only if x comma y equals to 0. X and y are 0. Both are 0. Right? So what is my actually question? If x is non-zero, you take this option. If x is equals to 0, you can take mod of y. Yes or no? Yes or no? So if you take x is equals to 0, what happens? If you take x is equals to 0, if you take x equals to 0, y equals 0, what is my first condition? If you take x equals to 0, y equals to 0, what is my first condition? P of x comma y. P of x y ఏమిద్దామా? ఇది తీసుకోవాలా, ఇది తీసుకోవాలా? ఏది తీసుకోవాలి ఆప్షన్? ఫస్ట్ తీసుకోవాలా, సెకండ్ తీసుకుంటారా? ఈ ఆప్షన్ తీసుకుంటారా?
సెకండ్
వన్. బికాజ్ x is equals to 0 అయినప్పుడు ఏం తీసుకోవాలి? mod y తీసుకోవాలి.
mod y.
బట్ y అంటే ఏంటి? 0. Right? So P of x comma y 0. One way is okay. What is converse? If P of x comma y 0, what is mean by, what is aim? I want to show that you need to check whether x comma y equals to 0 or not? You need to check it. Yes or no? See, ఇక్కడ చూడండి అమ్మా, x non-zero అయితే mod x is always positive. ఇది మనకు సంబంధం లేని కేసు కదా. x non-zero అయితే mod x is always positive. Yes or no? Mod x is 0. Yesterday I told you that mod x is 0 whenever x is non-zero. Mod x is positive whenever x is non-zero. So ఈ కేసు నాకు అవసరం లేదు, because I need to have p of x comma y must be 0. I need to inquire that. I need to inquire the option in which case p of x comma y must be 0. So in this case p of x y is not 0. I don't require this option. What is p of x comma y? Mod y. Mod y 0 if and only y 0. Yes or no? Yes or no? So when do you say that p of x comma y is equals to mod y? If when do you say that p of x comma equals to mod y? If x equals to 0.
X equal to 0.
So x is equals to 0, y equals 0 option. So first way is true. First is true. Is it clear? ఇక్కడ నాకు అవసరం లేని ఉంటే p of x comma y is 0. Is it 0? In which case? So p of x y is positive whenever x is non-zero. Whenever non-zero, I don't require this case because I need actually p of x comma y to be 0. So I don't require this option, first option. Therefore, you need to go through the second option, mod y. When do you say that this is mod y? Whenever x is equals to 0, right? P of x comma equals to mod y whenever x is equals to 0. Therefore, mod y equals to 0. Therefore, that is equals to 0. Therefore, x equals, right? So what is the second option? P of x y is non-negative function. Is it true? Answer yes. Because there is a mod, no? There is a mod symbol instead, no? So whenever mod is there, always non-negative.
Non-negative.
So this is non-negative, this is non-negative. In both cases, is non-negative, total non-negative. So this is over. What is third one? So second option is true. What is third one? If you take, see what are the conditions, you know? See, look at the condition, do it. You need to work with the condition x non-zero, x equals to 0. So if you take x equals to 0, what happens? I need to show that p of alpha x, alpha y equals to, you need to check p of alpha x, alpha into 0, comma, alpha y. That is nothing but p of 0, comma, alpha y. That is nothing but whenever x is 0, what is your option? Whenever x is equals to 0, what is option? Mod y. Means mod alpha y. That means mod alpha and mod z1, z2 is equals to mod z1 into mod z2, right? So mod y is same as saying that mod y can be written as p of 0 comma y. But p of 0 comma y, what is 0? X. What is 0? X. So therefore, in x is equals to 0, this condition hold. This condition hold. In x is equals to 0, you have shown that this is 0. What about x non-zero? If x non-zero, p of x comma alpha y, right? If x is non-zero, what is that? What is that? What is the case you are going to take?
Mod x.
Mod
Plus
x.
alpha x.
That is nothing but mod f. So mod of x, sorry, mod of x. That is nothing but mod x into p of x comma y. So these are redundant, Amma. These are redundant. So this option is redundant. Right? This is straightforward, right? X is equals to 0, we have done it. X non-zero also we have done it. Therefore, in both options we have done it. Therefore, this is true for all cases. What about this condition? Right? We need to guess that. You need to guess whether the inequality fails or not. See, this is very important. Why? Because it is asked in CSIR. It is asked in CSIR. It is a part C question. So you need to guess, because you need to have a very strong willpower, strong guess power. Is it clear? So I need to take x1 is equals to 6, x2 is equals to minus 6, y1 is equals to 7, y2 is equals to 7. Right? Right? So what you get is p of, what is my x1 plus y1? x1 plus x2. x1 plus x2 is 0. Right? What is my y1 plus y2? y1 plus y2 is 14. So p of whenever x is 0, what is my option? Mod 14. Yes or no? Mod y. So this is nothing but mod 14 is nothing but 14. Therefore, left side is 14. You are getting left side is 14. What is your right side? What is your right side? Right side is p of x1 comma y1 plus p of x2 comma y2. So p of x1, what is x1? 6. What is y1? 7. So whenever x is non-zero, what is your option? Mod 6. So this is 6. What is p of x2 comma y2? P of x comma y2 is nothing but, what is x2? Minus 6. What is y2? Y2 is 7. So whenever x is non-zero, what is your option? Mod 6. Mod minus 6. Mod minus 6 is nothing but 6. So this is 6, this is 6. Sum is 12. Therefore 14. Is it less than 12? Is it less than 12? No. So contradiction. Therefore this is wrong. Understand? Is it clear?
Yes, sir.
Yes. Okay, with this 15 CSIR problems are solved. CSIR, one of them get problem. Okay, these are only about metrics, only metrics. Okay, we'll take some break. Okay, 5 minutes.
ఓకే సార్ ఒక 5 మినిట్స్ బ్రేక్ తీసుకోండి. జస్ట్ ఇట్ ఈజ్ టీ బ్రేకా లేకపోతే వాటర్ బ్రేకా ఏదైనా అనుకోండి, కొంచెం రిలాక్స్ కండి. మళ్ళీ మనము ఎగ్జాక్ట్లీ ఎంత అయిపోయింది టైం? 7:30 అయిపోయింది. 7:36 కి జాయిన్ అయ్యింది. ఓకేనా?
What means cos k equal? Mean cos k equal. Whenever p bigger than equals to 1, whenever p bigger than equals to 1, when you have two n tuples, suppose you can have x1, y1, sorry, x1, x1, x2, x1, x2, x3, going on xn, y equals to y1.
Sir, which inequality, sir?
Means cos k inequality. Right. Means cos k or means cos k inequality. Y3, yn. When you have two n tuples in R power n, this is what means cos k inequality tells you. Summation I equals to 1 to n modulus of xi plus yi whole power p whole power 1 by p is always less than or equals to summation I equals to 1 to n. When you go through the functional analysis, you know this inequality. Famous inequality means cos k. Whenever p bigger than equals to 1, you need to use it. This is first inequality, very famous inequality. What is my second inequality? Holder's inequality.
Sir, you are sharing this note, sir.
Yeah, I'll share these notes. Right? What is Holder's inequality tells you? Whenever p bigger than 1, q is such that 1 by p plus 1 by q equals to 1. Same for a same n tuples. What is the inequality? Summation I equals to 1 to n mod of xi yi less than or equals to summation I equals to 1 to n modulus of xi whole power p whole power 1 by p into summation I equals to 1 to n mod of yi.
So here p greater than 1, q is what, sir?
Q is such that 1 by p plus 1 by q equals to 1. Q satisfies this condition. 1 by p plus 1 by q equals to 1 whenever p bigger than 1. Is it clear? That means suppose if you take p equals to 1, what is your proof? 1 by p plus 1 by q equals to 1. We need to use it. 1 by 1 plus 1 by q equals to 1. That means what? 1 by q equals to 0. That means what? Q equals to infinity. Suppose p equals to 2. 1 by 2 plus 1 by q equals to 1. That means what? 1 by q is equals to 1 by 2. That means q equals to 2. Is it clear? In fact, p must be bigger than 1 for Holder's inequality. This is what actually Holder's inequality. So why I'm using this? I need to use to solve the problem which is in CSIR. Right? So suppose R power n dp x comma y. What is my dp x power y? Summation I equals to 1 to n mod of x minus y whole power p whole power 1 by p whole power 1 by p, p bigger than 1. Whenever x is n tuple, y also n tuple. Right? So this is my distance function, p bigger than 1. Question is that is it a metric? Is dp is a metric? The answer is yes. This is LP metric. These are the standard metrics. You need to know it. Is it a metric? Answer yes. Why? Because first condition is redundant because modulus is there. Therefore, dp of x comma y, LP metric is always non-negative because modulus is there now. Mod of x minus y is always non-negative. Whole power p is always non-negative. Whole power 1 by p is always non-negative. This is true for every x comma y. So dp, distance between x comma y is 0 if and only if summation I equals to 1 to n mod of xi y whole power p whole power 1 by p equals 0. So mod is 0 if and only if each one of them is 0 for every one. That means xi equals to 1. That is x equals to 1. This is true for all. These are the redundant conditions. Symmetry property also direct because there is a modulus. What is triangle inequality? This is important. Summation I equals to 1 to n. I need three elements which are n tuples x1, x2, xn. Y equals to y1, y2, yn. Z is equals to z1, z2, zn. Right? So what is my xy definition? Distance between x and y is nothing but this summation I equals to 1 to n mod of xi minus y whole power p whole power 1 by p. While it shows the triangle inequality, this can be rewritten as I equals to 1 to n, adding and subtracting z minus yi whole power p whole power 1 by p. So by using last Minkowski inequality, this is my a, this is my b. So p bigger than 1. You know that p bigger than 1. So whenever p bigger than 1, this can be written as my Minkowski inequality. This is my a, this is my b. This is ai, bi. So summation ai whole power p modulus plus summation I equals to 1 to n bi modulus bi whole power p. That means mod of zi minus yi whole power p whole power 1. So therefore, this is my d of x comma z. This is my d of z comma y. Therefore, it satisfies triangle inequality. Hence, it is a metric. It is nothing but LP metric. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Yes. So p bigger than equals to 1 is okay. But the thing is, what about p lies between 0 to 1? What about remaining cases? Suppose if p lies between 0 to 1, what about these cases? R power n dp. dp is nothing but summation I equals to 1 to n mod of xi minus yi whole power p whole power 1 by p. Is it a metric on R power n? The answer need not be. Why? Because see actually the thing is that non-native there is no problem. Symmetry also no native problem. And second property also no problem. What is the problem? Third triangle inequality. So suppose you take actually 1 0 0 0 0. My y is equals to, you take actually 0 1 0 0 0 0. My z is a 0 vector. Right? What is my distance function? X comma y. 1 minus 0 whole power p plus 0 minus 1 whole power p going on 0 whole power 1 by p. That is nothing but 1 power p means what? 1. This is 0 minus 1 modulus means 1. 1 power p whole power 1 by p. That means 2 power 1 by p. What is mean by distance between x comma z? Distance between x comma z is distance between here to here. That means 1 power 1 by p, because 1 minus 0 whole power p plus 0 minus 0 whole power p plus 0 minus 0 whole power p whole power 1 by p. That is 1. Similarly, distance between z comma y. That means what? Z comma y is nothing but what? This to this. This to this. 0 minus 0. 0 minus 0 plus 0 minus 1 whole power p, here whole power p, going on, mod 0 minus 0 whole power p. That means what? 1 power p, here whole power 1 by p is there. So here whole power 1 by p, this is nothing but 1. So what you observe? Distance between, just wait a moment. Distance between, what you observe? Distance between x comma y is 2 power 1 by p. 2 power 1 by p is always bigger than 2. Yes or no? Why? Because p lies between 0 to 1. 1 by p is bigger than 1. Whenever 1 by p bigger than 1, 2 power 1 by p is always bigger than 2 power 1. 2 power 1 by 1 can be written as 1 plus 1. 1 is nothing but distance between x comma z. This is nothing but z comma y. So triangle inequality fails. Therefore, it is not a metric. So dp is not a metric. dp need not be metric whenever p lies between 0 to 1. Right? What about p negative? What about p negative? What about p equals to 0? In fact, if what about p equals to 0? P p equals to 0 means what? This something 0, something power 0, 1.
Constant.
So this is a constant. So constant, it not be a metric. What about negative? Whenever it is negative, distance function never be meaningful. It can be infinity. Whenever something p is negative, what you're getting, summation I equals to 1 to n, 1 by mod of xi minus yi whole power p. Right? I can put x is equals to c 1 0 0 0, y equals to 1 0 0 0, same vector. So x minus y is 0. So this is 0 vector, something 1 by 0. So it is infinite. Therefore, it is not metric. So p less than 0, it is not a metric. P equals to 0, not a metric. P lies between 0 to 1, also not a metric. So what is this? LP metric is a metric. LP metric is a metric. DCP is a metric on R power n if and only if p is bigger than or equals to 1. Is it clear the idea, madam? Is it clear? Is it clear, all of you?
Okay, sir.
Okay. Okay, now we can solve the question. మీరే సాల్వ్ చేయండి అమ్మా. క్వశ్చన్ మిగిలిపోయింది కదా, నేను చూడలేదు. సో సాల్వ్ చేయండి. ఓకే, p lies between 0 to 1 ఉంటే మెట్రిక్ కాదు. ఓన్లీ p bigger than or equals to 1, that is a metric. Okay. Okay. Next.
సార్ ఒకసారి మీ మైక్ కొంచెం దూరం పెట్టుకోండి సార్, వాయిస్ అటు ఇటు అవుతుంది.
Okay, okay sir.
ఒకటే వేలో పెట్టేసుకోండి సార్.
Now it's okay sir?
Now okay sir.
Okay. Now I can extend this idea to sequences. Suppose, see, so this is my second example. I already told you, already we have shown that this is a metric, L infinity metric. What is L infinity metric space? D infinity is equals to D infinity of x comma y, D infinity of x comma y, x comma y is equals to maximum of mod of x minus y. Already we have shown that this is a metric. Yes or no? We have shown that it is a metric. This is L infinity metric. We have shown, yesterday we have shown, look at your notes, okay? Look at your videos. So we have shown that it is a metric. So dp is a metric. dp is a metric on R power n whenever it is a maximum if p equals to infinity. P bigger than or equals to 1 or p equals to infinity. Yes or no? This is straightforward, we have shown. And we can extend this idea. This is n tuple. First we have given an example for R. We have given example, we can extend the idea to R square, and we have given a matrix on R power n. Next we can extend this idea to sequences. That is what our idea. So L1 sequences. Suppose you can take x is equals to x1, x2, xn going on. It's a sequence, right? It's a sequence which is in a sequence function from n to k. Sequence is nothing but a function from n to k. It's a sequence. It's a first summable sequence. Means what? Absolutely is a convergent sequence. Simply say that it's a set of all, space of all, absolutely convergent sequence. Right? You can take this LP also. You can take this in LP. P bigger than or equals to 1. So what is the metric I am giving? So d of f comma y is equals to summation I equals to 1 to infinity xi minus yi whole power p whole power 1 by p. You know, this series is convergent. This series is convergent means, so when you take x is equals to sequence, LP sequence, this series is convergent. When you take y is equals to LP sequence, is a sequence, this series is convergent. Right? This series is convergent. So automatically, this series is convergent. Why? By means cos k inequality. You take any n, xi minus yi, any n you consider whole power n, whole power p, whole power p, whole power 1 by p. By means cos k inequality, this is nothing but summation I equals to 1 to n mod of xi whole power p whole power 1 by p, summation I equals to 1 to n mod of yi whole power p whole power 1 by p. You know this sequence is LP sequence. Therefore, it's a convergent series. That means what? This corresponding series is convergent. That means this is always less than or equals to summation I equals to 1 to infinity xi yi whole power p whole power p 1 by p. Summation I equals to 1 to infinity yi whole power p whole power 1 by p. But this is nothing but what? Your sequence. You know that this series is convergent. You know that this whenever it is in LP, this corresponding series is convergent. This bracket series is convergent. Whole power 1 by c is p also convergent. This bracket 1 is convergent. Whole power 1 by p is convergent. Therefore, it's finite. So therefore, this is finite for every n. This is finite for every n. So nth partial sum of the series is convergent. So that means what? This series corresponding series is convergent. Why? Because this nth partial sum is convergent. This is exactly nothing but nth partial sum of this series. A series is convergent if and only its corresponding nth partial sum is convergent. So therefore, this series is convergent. This series is convergent means what? What is this? D of x comma y. Therefore, what? This is a finite real number. So it is a real number. It is non-negative real number because its modulus is there. Right? It is a finite real number. Is it clear, Amma? Is it clear?
Yes, sir.
Yes. So therefore, so it is non-negative real number. Second property is trivially whole. Second property is trivially whole.
Take
Third
another
property
page.
also.
Take another page.
Problem with this. Problem. So D of first property clearly true is non-negative. Second property also trivially true because modulus is there. Third property also trivially true. What is fourth property? Again, means cos inequality. Using means cos inequality. So what is this? This is nothing but same strategy. Summation I equals to 1 to n. Need to take into same strategy. What is this? T of x comma y. You need to take summation I equals to 1 to n mod of xi minus yi whole power p whole power 1 by p. Right? This can be rewritten as summation I equals to 1 to n xi adding and subtracting zi. See, using previous techniques, that's what actually mathematics. So therefore, again means applying means cos inequality I equals to 1 to n xi minus yi zi whole power p whole power 1 by p plus summation I equals to 1 to n x zi minus yi whole power p whole power 1 by p. You know, this is a convergence series. You know that, this is true for every n. In fact, this is a convergence series because x comma y where x comma y are which are in LP. X comma y are in LP means what? X minus y is in LP. X minus z is in LP. Z minus y is in LP because it's a vector space. Later will show that in function analysis, it's a vector space. LP is a vector space. In fact, it is a nonlinear space. It's a Banach space. So therefore, it is always convergent. X minus z is in LP. Therefore, its corresponding series is convergent. So this is always less than or equals to this, right? So this is always less than or equals to summation I equals to 1 to n 1 to infinity zi minus yi whole power p whole power 1 by p. Right? This is nothing but what? D of x comma z plus d of z comma y. You know, this partial sum, nth partial sum, because I'm taking for any I equals to 1 to n. So this partial sum is bounded above by this. You know, it's a non-negative terms. It is bounded above by this. Therefore, by series test, whenever this is non-negative terms, this is bounded above by something. Therefore, this corresponding series is convergent. This series is also bounded above by this. In fact, this series is also convergent. This series is bounded by this. But what is this? D of x comma y. Right? So triangle inequality holds. Don't see some books, in some books directly one can use 1 comma infinity. Nothing wrong. If you take 1 comma infinity, also nothing wrong. But you need to prove the result for means cos inequality for sequence. What I told you, that means cos inequality for r power n, so that I can use y equals to 1 to n, and this is true for every n. Letting n tends to infinity, you can get the answer. Some books you can take directly sequences. So, but you know that means cos inequality also hold for sequences also. So this is a metric, right? This is a metric space. So therefore LP DP is also metric space, right? Similarly, L infinity, set of all bounded sequences is bounded sequence in sequence of scalars. So is it a, so can you give me a metric? Yes, I can give a metric. D infinity of x comma y. In fact, D. Don't take another notation. Some books mention D infinity, so nothing to take D infinity. For sake of our convenience, I don't want to take infinity for writing purpose. This is nothing but what? Supremum of xi minus yi, I belongs to n. So whenever x is a sequence, bounded sequence, which is in L infinity, y is nothing but what? It is also bounded sequence. Right? Right? So therefore, question is that, see, can you give me at least one bounded sequence? Yes, we can give so many bounded sequence. 1 by n such that n belongs to n. It's a bounded sequence. Suppose if you take, for example, it's a bounded sequence. It is bounded by 1, 1 by 2, going on 0. So 0 is lower bound, 1 is an upper bound. Right? So therefore, x belongs to L infinity. So it is a non-empty set. Later we will show in function analysis, it's a vector space, it's a non-linear space, of course. But I want to show that it's a metric. It's a well-defined function, yes. So what is my x? X is a bounded sequence. Y is a bounded sequence, because as you know that the elements in L infinity are nothing but bounded sequences. So x is a bounded sequence, y is a bounded sequence. The difference also bounded sequence. Therefore, x minus y is a bounded sequence. Mod is bounded sequence. Therefore, bounded sequence has a supremum, because any bounded subset of real numbers, non-empty, there's a supremum by completeness axiom. Supremum exists, it is finite. Is it clear? Is it clear, Amma? Hello, are you there?
Yes, sir.
Yes, sir. Okay,
Yes,
sir.
sir.
Yes. So first property is trivially true. First property is trivially true because supremum modulus is there. Second property is true directly. I don't want to prove it because these are redundant. Same lines, whatever you have done for R power n. Same lines, R power n, whatever you have done for R power n, same lines. What is a non-trivial? Triangle inequality. For this also non-trivial. Actually, this also trivial. We have done the same lines in a proof of R power n. You start with xi minus yi. You know, this is nothing but adding and subtracting zi. But is always less than or equals to xi minus triangle inequality, because these are the real numbers. In fact, this modulus, this xi minus y as a scalar, this is also scalar. Mod z1 plus z2 is equals to mod z1 plus z2, mod z2. You know that this is a single piece because I am fixing I. Therefore, this is always less than or equals to supremum. Supremum is nothing but what? D of x comma z. This is nothing but d of z comma y, because this element is bounded over by supremum comma z plus z comma y for every I. So therefore, it's an upper bound for the set this one over I. Therefore, supremum of this is a least upper bound. This is always less than or equals this. But what is this? D of x comma. Therefore, it is a metric. Triangle inequality holds. Therefore, it is a metric. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
So I'm going to complete within 5 minutes. Okay, just wait. So therefore, see, there is an inclusion. You know that, see, L1 is always subset of LB. See, in fact, L1 is subset of L2, L2 is subset of L3, going on LP subset of LQ is subset of going on L infinity. Whenever P less than Q. Why? Because what is meant by L1? When you take X is in L1 sequence, that means what? Summation I equals to 1. It's a first summable sequence, right? First summable sequence. It is in L2 by Minkowski inequality, but the proof is different in function analysis. This is always true by Minkowski inequality, but when you deal with function analysis, you know this result. So by Minkowski inequality, this is always true. But what about the converse? Converse may not be true. Suppose you can take the sequence 1 by n such that n belongs to n. 1 by n such that n belongs to n. It is in L2. Why? Because summation I equals to 1 to infinity, this whole square summable sequences, because mod of 1 by n is nothing but 1 by n, this whole square. This by p test, it is convergent. Therefore, 1 by n sequence which is in L2. So 1 by sequence is in L2, but 1 by n sequence does not belongs to in L1 because this series is divergent. This series is divergent by p test. Of course, it is not Cauchy sequence. Nth partial sum is not Cauchy. So therefore, it is a divergent sequence. It is in infinity. Therefore, it is not in L1. Therefore, L1 is subset of L2, but L2 is subset of L3. L3 is subset of LP. LP is subset of LQ. LQ is always subset of L infinity, because to take any x is in L1, automatically what happens? Summation I equals to 1 to n. This is in xi. This is finite. It is convergent sequence. So therefore, nth term tends to 0 as n tends to infinity. So any convergent sequence is bounded. Therefore, xi is bounded. You know that every convergent sequence is bounded. Therefore, xi is bounded. Therefore, see, this sequence is in L infinity. Therefore, L1 is always is in subset of L infinity. Of course, L2 also subset of L infinity, because every convergent sequence is bounded. Is it clear? When you deal with function analysis, you know it.
Yes, sir.
Is it clear?
Yes, sir.
Yes. Right. So so this is nothing but actually what this is another version of. So when you take a metric space x comma d, when you take x comma d is a metric space, when you take x comma d is a metric space, this there is a problem. So x comma z, this is standard inequality by using triangle inequality. Less than or equals to d of x comma y. One can prove this by using triangle inequality. X comma y comma z belongs to x. D of x comma z minus d of y comma z always less than or equals to, this is z. D of x comma z minus d of y comma z all modulus is always less than or equals to this. Again, you know the distance between x comma y minus distance between a comma b modulus is always less than or equals to distance between x comma a plus distance between y comma b by using triangle inequality. One can easily prove it. Right? Again, you know that there is another example. Bounded sequences, bounded functions. What do you mean by bounded function? A function which is a real valued.
Sir, is it triangle inequality?
Yeah, using triangle inequality, one can prove it, Amma. I don't want to prove it because these are straightforward questions. Okay, using triangle inequality, you can take any Rodin book.
But it is reverse of triangle inequality, no, sir?
It is not like using triangle inequality, one can prove this inequality. It is not triangle, but it is one can prove these results, these inequalities by using triangle inequality of the matrices, because you are given that x comma d is a metric space. Is it clear? Using triangle inequality, one can prove these inequalities. That's what my point. Is it clear? Is it clear, Amma?
Okay, sir. But by using triangle inequality, it is converse of that, no, sir?
Yeah.
That's the proof.
Yeah. Hello. Pardon.
So by using triangle inequality for the first line, actually d of xy is less than or equals to that right side value, right?
Yeah. D of x comma z modulus of d of x comma z minus d of z comma y comma z less than or equals to d of x comma y. Is there any doubt?
By triangle inequality, it is proved.
See, look at it. I'll prove it.
No, sir. I'm అడిగేది ఏంటంటే
no need, sir.
మేడం ఈ రిజల్ట్స్ అన్ని ట్రయాంగిల్ ఇన్ఈక్వాలిటీస్ ని యూజ్ చేసి ప్రూఫ్ చేసుకోవాలి. ఇది లెంతీ ప్రాసెస్. డైరెక్ట్ స్టేట్మెంట్ గుర్తుపెట్టుకోమంటున్నాడు. లేదంటే మరి ట్రై చేస్తే రూలింగ్ టెక్స్ట్ బుక్ చూడొచ్చు.
అదే సార్, అర్థమైంది.
Is it clear?
Okay, sir.
Yes, sir. Yes, sir.
What is your doubt, madam? Actually, I'm not getting your doubt.
Yes, sir. We can prove by using triangle inequality, you said, no?
Yeah.
But the first line seems to be like triangle inequality.
It is not triangle. It is not. Is it? Modulus is there, na? Modulus is there. Na?
Yes, sir. Now understood.
Yeah, that's what my point. It is not triangle inequality.
Yes, sir.
So it is. So take a bounded function. So what is it is also vector space. It is a normal linear space. With respect to this function, d of f comma g is equals to supremum of by the same lines. I don't want to prove it. This also metric, because it is a standard function. F is bounded, g is bounded, modulus is bounded, mod of this also bounded. Whenever a function is bounded, supremum always exists. It is small finite real number. Again, same proof. Whatever lines you have done for the LP, the same lines, you can prove it. Is it clear?
Yes, sir.
Right. Next, you have a metric spaces. Suppose you can take 2 cross 2 matrices. This is like looking like NPHM question, like this, National Board of Higher Mathematics. So distance function d of a comma b is nothing but summation. So when you're given a matrices a1, a2, a3, a4, b equals to b1, b2, b3, b4. Suppose these 2 are 2 cross 2 matrices. What is my metric is summation I equals to 1 to n, looking like L2 metric. I equals to 1 to 4 modulus of ai minus bi whole square whole power 1 by 2. So it is by unit means cosine equality, it is a metric. So therefore, this D is a metric on set of all 2x2 matrix over a field R. Is it clear? By same means cosine equality, see, remaining properties are trivial, na? Because it's the usual distance, na? Euclidean distance, na? Distance between 2 points, A1, A2, A4, B1, B2, B4. This is a point, this is a point. Euclidean distance, under root of A2 minus A1 minus B1 whole square, A2 minus B2 whole square, A3 minus B3 whole square, A4 minus B4 whole square. You know that in vector space, in fact, this 2x2 over R is isomorphic to R power 4, R. Right? It is isomorphic to R power 4 because the dimension is same. Therefore, this is a metric. In fact, they are isometric. In fact, it's isomorphism, isometric. The distance preserves. So therefore, it is a metric. It is a metric. I can use this idea in continuity. Remember this idea. It is a standard metric on M2 cross M2. M2 2 cross 2 over R. This is a standard metric. I can use this idea in continuity. Remember this idea. Is it clear? See, one can prove is easily. Yes or no? The same lines. Whatever you done for R power n, R power 4, the same lines. Yes or no?
Yes.
Is it clear?
Yeah.
Okay. Yes, sir.
See, with this metric is complete. With the metric is complete. Tomorrow I'm going to start